Alright, in lesson 10.5 we start to look at what's called inscribed angles. So let's go through just the little notes and definition part, and then we'll work some of these problems out. An inscribed angle is an angle with its vertex on the circle with two sides that are chords. Okay, so let's look at that for a second. So we have an angle inside the circle. The vertex, here's B, angle B is the vertex. It's on the circle, and then each side of the angle is a chord. So remember, a chord is a segment that's endpoints are on the circle. So we have side BA and side BC are the sides of this angle, and the vertex is on the angle, therefore angle ABC is inscribed in the circle P. Alright, an intercepted arc is the arc that lies between the endpoints. An arc that lies between the endpoints of an inscribed angle. So the arc that is intercepted is arc AC, okay, because it's between these two endpoints A and C. Okay, so arc AC. The measure of the inscribed angle is equal to half the measure of the intercepted arc. Okay, so the measure of this angle ABC is going to be half the measure of arc AC. So if we know the arc measure, we can half it, and that will be equal to the inscribed angle, or if we know the inscribed angle, we can double it and we'll know the measure of the arc. Now if you remember back when we did central angles, they were actually equal. The central angle started in the center, and then the two sides of the angle were radii, and we said that the measure of the central angle was equal to the intercepted arc. Okay, but this one is half. Okay, so a couple special cases here. We can have the arc that's intercepted could be a diameter, right? It could go through a diameter. So here, if an inscribed angle intercepts a diameter, so look, we have this angle angle BAC, and the endpoints here are actually half of the circle. Okay, well, let's think about that for a second. We said up here that the arc is always twice as much as the inscribed angle, or the inscribed angle is equal to half of the arc. So if we just said this is half of the circle, because the diameter cuts the circle in half, so this would be 180. Well, half of 180 is 90. So that means anytime we have an intercepted diameter, that inscribed angle is going to be a right angle. Okay. So because it intercepts the diameter. Okay. Then we have a case with overlapping arcs. If two inscribed angles intercept the same arc, then the angles are congruent. So in this figure, the measure of angle ABD, because they intercept arc AD, are going to be congruent to angle ACD because it also intercepts AD. So even though they look different, the lengths of the sides look different because they both intercept the same arc on the circle, arc AD. That tells us that they're congruent. So the measure of angle ABD is congruent to the measure of angle ACD. Okay. Now we can use this information to solve some problems down at the bottom of the page. So let's scroll a little bit, and we'll work through some of these together. Okay. So number one. All right, we have the inscribed angle WXY, and then we have the arc labeled. Okay, where our notes at the top said that if we half the arc measurement, we get the inscribed angle measurement. So half of 62 is 31. So this angle is just 31 degrees. Okay. For number two, here we're given the inscribed angle. So it's kind of the opposite of number one. So if we take that and just double it, we get 226 So the measure of the arc, DF, or DGF because it goes through G, would be 226. Okay. Measure of angle PQR, okay, that's this one. So we have a case where the inscribed angle is a diameter. See that? Okay, so we said anytime that I said inscribed angle, I meant the intercepted arc. Anytime the arc that's intercepted is a diameter, that means the inscribed angle is going to be a right angle. So this is 90 degrees. Okay. All right, on number 4, we've got a little bit different scenario because of what we're being asked to find. They're asking us to find arc BC, which is this one. All right, so we're given a couple of things. One, sort of obvious one, and then a second one that you have to kind of maybe take a step back to see. So first of all, if this is 47, we know that this is going to be twice that. So here, this arc AC is going to be 94 because 47 times 2 is 94. We know that this one has to be 180, right? Because we have a diameter here, which cuts that circle in half. So arc AB over here is 180. Now, there's a couple of different ways you can look at it going forward. We can just do some simple subtraction. You can think of this as if this half is 180, then this half has to be 180. So I can just do 180 minus 94, which will give me 86. I also could have done 360, which is the entire circle, minus 180 minus 94, which will be 86 degrees. So for number 4, we have 86 degrees. Okay. Number 5, similar situation here. We know that the entire circle has to be 360, right? Okay. So then to find this arc measure, we can just subtract 65 and subtract 53, and we get 242. Okay, which is the arc measure. So the arc measure is 242, but here we're asked for the angle measure. We want to know what is the inscribed angle. So remember, it's always half of the intercepted arc. Okay, so 121. All right, this goes with the overlapping arc notes that we took up at the top of the page. So we're asked to find RST, which is this one, and the measure of angle RUT, which is this one. Now, since they both intercept the same arc, right, arc RT here, that means they have to be equal. So if we find one, we found them both. So we just need to know what is this arc measure. If we find the arc measure and we half it, then we'll know both of these angles. So again, if you start with 360 and you subtract 64 and subtract 75 and subtract 139, we end up with 82. And then if we half that, we get that each of these is going to be 41 degrees. This is always half of the inscribed arc. Oh, excuse me, of the intercepted arc. All right, let's look at 7 and 8. So number 7, we introduce a little algebra, but it's pretty straight up. We know that this angle is equal to half of 158. Okay, well, what's half of 158? It's 79. So 79 is equal to 8x minus 9. Okay, so if I add 9 to both sides, I get 88 is equal to 8x. Divide both sides by 8, and we get x is 11. And remember the directions here. Instead of finding an angle measure or an arc measure, they just simply ask us to find x. Okay. For the next one, similar situation, but we flipped where the variable is. Here we had the inscribed angle is where the x was. Now the x is on the intercepted arc. So if I look at that, I'm given 67. I know that 67 is equal to half of the intercepted arc, so I'm going to put half of 4x plus 58. Okay. So if I half both of these things, think of the distributive property. If I half 4x, that would be 2x. If I half 58, that would be 29. So 67 is equal to 2x plus 29. subtract 29 from both sides, and I have 38 equals 2x. And then we can divide both sides by 2 to get 19 for x. Okay. We're going to move to the next part, next page on 10.5, and just do a couple of these. I think hopefully you're starting to get the hang of it by now. They're all pretty much using the strategies we just used, just sort of over and over. Maybe you may have to be sort of clever a few different times to figure out exactly how to use it. But the problems on the back are pretty much the same as the problems on the front. We're going to do 2 of them. I'm going to do number 12 with you and number 16, and I'll leave the rest of them for you to practice. So for number 12, we are asked to find x. Okay, we see that it's on the arc. I know this arc measure. I know that all of the arc measures have to add up to 360 because they're part of a circle. So if I can find this one, I think I can get there. This is an inscribed angle, so if we double it, we would get 134. So this arc has to be 134. Okay, now the whole thing is 360. If I subtract 120 and then I subtract 134, I'm left with 106. Okay, so that means this 5x plus 21, we know by subtracting from 360 that it's actually equal to 106. So then if I solve, I get 5x equals 85. Subtract 21 from both sides, and then divide both sides by 5, and x is 17. X is 17. Okay, the last one for 10.5, we're going to skip all the way down to the bottom and take a look at number 16. Okay, so let's see. If the measure of angle KJL is 3x plus 2, so KJL is in here, that is 3x plus 2, and the measure of angle KLJ, so that's this one, and it is 7x minus 32. Find the measure of arc KL. Okay, so arc KL is this one. Alright, well, let's see. The first thing I know is that this angle, this inscribed angle, is intercepting a diameter. So that means this is actually a right angle. Okay, this is 90 degrees because it's intercepting a diameter. So this arc would be 180, and then we were left with half of 180 is 90, so this angle has to be 90. So this is a right angle. Okay, so if this is a right angle, that means these two angles combined also have to be 90, because 90 plus 90 is 180. So because it's a right angle, 3x plus 2 plus 7x minus 32 has to equal 90. Okay, so if I combine like terms, I get 10x minus 30 is equal to 90. Add 30 to both sides, so 10x equals 120, so then x is 12. X is 12. Okay, now I was asked to find arc KL, right? Well, we know that arc KL is twice this angle over here. So if I substitute 12 in for 3x plus 2, I would get 3 times 12 plus 2, that's 36, plus 2, which is 38. And then if I double it, 38 times 2 is 76. So the measure of arc KL is 76 degrees. Okay, so like I said, you're using those same few strategies that we learned at the beginning of this lesson, just sort of over and over. You may have to think outside the box a few times, but I don't think you'll have too much trouble finishing up these problems.